Okay, so this is a problem about a football punt. So it says when a football is kicked, the nearest defensive player is 6 feet from the point of impact with the kicker's foot. Okay, so I'm going to try to draw a little guy here kicking the football. Okay, and I guess he has to hold the football. So he's going to punt. And I guess he should have a football helmet on or something. Okay, anyway, he's kicking this football that's right here that I'm trying to make look like a football. And he's going to kick it. And the ball's going to go up, and then the ball's going to come back down like a projectile. And somewhere there's a defensive player here. I guess he has a helmet on too. We'll make it red so because he's on the other team. Okay, there we go. And he's going to try to, block the punt. Whatever, he's going to reach up and try to block it. Okay, now he's 6 feet away from the ball. Okay, so just keep that in mind. The height of the ball. So this is this arch here. That's the path. That's the trajectory. That's the parabola. Okay. It is given by this equation right here. So they give us an equation for that parabola. And it says x is the ball's horizontal distance. So the ball's going to be here, and then it's going to be 3 feet or 8 feet down, and then 10 feet down, and then 12 feet down, so many feet down the field. Okay, that's the horizontal distance. Not how high up in the air it is, but just how far down the field it is. All right, that's the horizontal distance, x, from the point of impact. Okay, the point of impact's where he's actually kicking the football. Okay. What's the maximum height of the punt? And how far from the point of impact does it occur? So in other words, what's the vertex? You've got the formula. It's a quadratic formula. By the way, it's upside down. It's it's a parabola, so it's going to have a maximum height, and that's what we're trying to figure out. So what would we do? Well, we would say h is equal to the opposite of b over 2a. And in this case, my b is 1.18, and my a is negative 0.01. So I could put that in a calculator. What do I get? Let's see, negative 1.18 divided by, and then you'll have to put that in parentheses, 2 times negative 0.01. This is one way you could do it anyway. And I get 59. Okay, so h is 59. Now, that is, we're trying to find the vertex h comma k. So that is the x value, 59. 59. And then to figure out k, you're going to have to find f of 59. So you're going to have to plug that in. It's going to look like negative 0.01 times 59 squared plus 1 times 1, I'm sorry, plus 1.18 times 59 plus 2. So go ahead and put that in your calculator. I'm going to turn off the video and put it in my calculator, and then I'll come back. Okay, I'm back. So I got a 36.81. I don't know how accurate they want it. Okay, so what does that mean? It means the maximum height is, and this is what they're asking for, the maximum height, that's the output, is about 37 feet, but we'll say 36.81. So that's equal to, it's not approximate. So 36.81. So that's how high up it's going in the air. And it occurs 59 feet down the field. Oops, I forgot to put this in feet. 59 feet down the field, down from the punter's foot, down the field, or from the point of impact. I should say from the point of impact, from the point of impact. Okay. How far must the nearest defensive player reach to block the punt? Okay, so remember the nearest player, defensive player, 6 feet away. So that's x being 6. Okay, so what's the height then when x equals 6? So what's f of 6? Well, we're going to put it in our formula, in our function. And then we're going to have to figure that out. So use your calculator. Okay, so I got 8.72. So the nearest, he's got to reach. So he's got to jump up and reach 8.72 feet to block that punt. And he probably just can get, a little finger on it and that will probably block it. But anyway, okay, it's football season. I like football. So that's how far he'd have to jump up and reach, though. Okay, if the punt is not blocked, how far down the field will it go before hitting the ground? Okay, so if it's hitting the ground, then the height is 0. And remember, our function is telling us the height. So when does f of x equal 0? And that's going to be like, when does, well, let's see. So what was our function? Negative 0.01 x squared plus 1.18 x plus 2. Now, that is a quadratic function. It's set to 0. I would use a quadratic formula for that. Okay, so the opposite of b plus or minus the square root of b squared, 1.18 squared, minus 4 times a, negative 0.01 times c, all over 2 times a. Now, when you're putting this in your calculator, you're going to have to put parentheses around this, and you're going to have to put parentheses around this. Brackets or parentheses. Usually the calculators now just have parentheses. Mine just has parentheses, but sometimes you'll see the brackets too. But make sure you put those in, because if you don't, you're not going to get the right answer. So it's going to take you a while to put this all in a calculator. You could also do it in pieces. A lot of students do that. But I probably would just put it all in at once. Okay, and you're going to do a division bar here. Okay, so I'm going to stop so I can do that on the calculator. One more thing, you're going to have to decide whether it's plus or minus. Um, it could be either one. So you're thinking about this parabola that's happening. Well, the ball is in the air when it's kicked, so it wouldn't be on the ground until it's further down. Okay, so just keep that in mind. There's probably only going to be one positive answer. Okay, so some things that might be helpful to you. When on my calculator, when I hit the square root, it automatically opens that parenthesis there, and the parenthesis there then has to be closed as well. I'm going to give you the keystrokes for putting this in a calculator, but you should have gotten, well, let's go through the keystrokes. Okay, so you're putting this in your calculator, and this is how you put it in. You're going to say parenthesis, negative 1.18. We'll do the addition case first, plus, and then square root. If your calculator's like mine, it opens a parenthesis. You can put 1.18. And then mine has a square button, but you can go exponent 2. And then I went ahead and made this plus because I've got a negative times a negative here. 4 times 0.01 times 2. Oh, you know what? I'm sorry. I was doing the keystrokes for you. So I don't put in all those parentheses when I'm putting this in. So let's get that 0.01 times 2. In fact, I did 4 times 2 and just put 8. But anyway, you've got to close that parenthesis off. Then you've got to close that one that matches to this first one here. Okay, so you have to have all that. And then divided by, and then parenthesis, and you're going to go 2 times negative 0.01. If it's a TI, most TIs, they have a little negative button. Don't use the subtraction button because it won't like that. Okay, when you do that, you should get about negative 1.7, I think. So it's not going to be a negative. That's if the punter is really bad and the punt went behind him. Okay. So it's not that case. Um, so now do the whole thing again, but use the minus. Okay. So do the whole thing again, but use the minus case. Okay. And then you're going to get, it's going to be 119.7 about. So that's how far down the field it went, like that many feet. Okay. And so that's going to be the answer. So we're assuming the punt did get blocked and that the punt went forward and it went down to 119. It went 119.7 feet. Okay. I forgot to graph the function. Okay. So, you would probably not do a huge grid here. We know a little bit. We know at 6 feet. We know at 0 feet. We can find f of 0. That's easy to do. If you plug in 0, you're going to get 2. And so that means the football is 2 feet off the ground when he actually kicks it. Okay, and then at 6 feet, it was what, like 8.7? Let's see if I can scroll back up. Yeah, it was like 8.7 feet. So if that's 2, maybe 8 is like there. And then when is it at 0? Now remember this is the x value, right? Okay, so that's like the horizontal distance, how far down it's going. Yeah. So that's going to be like 119 120 feet. And then we also knew the maximum was going to be like at 59, and that was like 36 feet or something like that. I don't know. This isn't very accurate, but you could get a better piece of graph paper, and then you could say, okay, well, then I know, a little bit about the shape here, but let's see. I don't have it drawn accurate enough. I need a better piece of graph paper. But it's going to go something up and then it's going to come back down. And anyway, it'll be a parabola and it'll be symmetric about this line right here, wherever it is. But I don't have it drawn very well. So, I probably should have got a piece of graph paper that would have looked better. But it's just a rough sketch. So I wouldn't expect you to graph something like this super accurately.